Yeah, hi. Good morning, everyone. Welcome to the IoT workshop session. Mm, in this session, we will be focusing on, we'll be doing a case study. So I'm just going to go through this case study for the for this project that uh, I did on the screen. So what this case study does is it is actually one of the first 5G urban farming case study. As you can see from the picture, this is a very dense container that we designed this so that it can host a lot of the urban farming in the entire 40-foot container. Yeah. So this is the background of the project. I was engaged by a startup called Boomgrow. The objective is to build an urban farm in a 40-foot container within 3 months. So the number of the time is like very limited. You only have like 3 months to build this one. This is going to be a fully customized design. So we will use everything is actually done, the fabrication, the frame, the structure, and the add-ons, and everything is all, it was done by the Boomgrow design team, how they will 3D draw everything out and then they get it fabricated by the metal fabricator. It's a fully customized design. One of their, they wanted the whole thing to be fully automated. So all the lights, all the fan, all the aircon, and all the cooling is actually fully customized for this one. And they wanted also a web-based remote control. So as this farm is located in Langkawi itself, we do not have a technical support team in Langkawi, so we would need a way to fully remotely control this from our HQ in Kuala Lumpur. So this is a very good example of an IoT solution with a combination of hardware, custom design hardware, and software from the firmware, from the services, like and also from the server side, and protocol IoT protocol working together on this one. So the project is, this one is very challenging, and then we have a small team and very limited time to get this one done. So these are some of the requirements for the project. This was discussed just like we just everything out on the paper and different system, fully automated farm. So everything is automated. So less the planting, everything else is fully automated. A high veggie volume, 40-foot container. So all the, it actually produce a lot of vegetable within such a small container. Multiple systems working together. So later I show you the system for the IoT, the systems for the security, the systems for the environmental sensors, the systems for the lights, the fan, and everything. Racks talking to the server. So we divide up into each and every rack. So we split up the container to what we call a rack system, and each rack would have around, one layer is around 5 row row by 8 columns, so it's around 40, and then we got 6 level of the rack. So it's like 240 vegetable per rack. And we have around like 15 racks or so. And then another requirement is that logging for all events. As this is a non-automated system, so minimal humans will be inside because we inject the CO2 inside the system. So this one, everything would have to be locked. Who opens the door, who closes the door, like the light is on, and so everything is being locked. Like a very, very closed system. And then of course dashboard for the entire system. So this dashboard will have all the system status and of course alert and notification, because if anything happens, either good or bad, temperature is high, temperature is low, door is open. Example, if the door is open at 3 a.m. in the morning, maybe there's a break-in, alert system needs to be generated because there's no human there all the time. And so all these systems are being talked about. So one side of the team very busy doing all the wiring and all the placement, all the physical racks, placement, all the place to put all the system like the switches, the server, the UPS, the electrical DB. My side was coming up with all these automation system to get the requirement going within a very, very short period of time. So these are some of the press and the picture. As you can see from the first picture, we have all the racks. We actually plan it in a different system. It is called a Kaki system for those that are familiar with farming. So we mix all the liquid and then we put inside a box. And when it's 14 days or 7 days, sorry, we will transfer the little plant onto this box here, you see in the picture. And then after 3 to 4 weeks, the plant would mature and then we would harvest it. So this system, we do not run any pipe or any water pumping and then to circulate the entire system. Like I think most of you would have seen what we call circulating system, where you run water from the top to the bottom to circulate the liquid fertilizer. So in this case, all of them, so we can with this you can see that if you count, they are like 1, 2, 3, 4, 5. There are 6 levels of tier onto it, and very, very narrow. And I think in the other end, we actually have a window where you can see inside from the other part. And the top here, you can see this little thing with a hole. This is the one that circulates the cold air together with the CO2 systems. This is a highly complex. The plants needs a lot of CO2 to grow, so we have to inject the CO2 from the CO2 burner. And then of course this is a news clipping. I think this is I think on the 10th of January 2000. Yeah. And then this one was launched by the then Minister of Malaysia. So as you can see, there are some other interesting article on the newspaper. We're not going to talk about that. And so let me start by showing you the video of the entire container. The container is now moved to Westin Langkawi. Let me just show you this video. I think it explains it much better. There you go. This is the germination part. So the tray you see here, this is the germination tray. for 7 days. As you can see from this picture, we are actually in Rusty in Langkawi, and we actually added an add-on at the front here. And see, this is the actual door of the 40-foot container. Is because we cannot have any extra space because we need to maximize the planting of the plant. So we have to build this add-on with some, as you can see, with some 5G antenna here and some other antenna, and also a camera here and a door here to open. So this part we actually add on to the container itself to maximize the planting. As you can see that there are actually two doors here, the outer door and the inner door. The outside here is for us to put all the water and all the mixing and all the other essential items. So this entire thing is a self-contained. We do not, all we need is just power and water supply. So this one can actually be deployed anywhere around the world if you just plug in power and water. So as you can see, we germinate this from the seed until 7 days. When they are this big, we will transfer them to the so this is how we transfer when they are like almost like this big to it. Okay, let me get back to my slides. Yeah, so this is the entire system. They consist of an IoT system in the middle, and that's what we call it. Then they are the rack system. They are their environmental system. This is things like CO2, temperature, humidity, and all the air-related system. There's a security system, consists of CCTV and doors and opening and closing of the door. They are the mixing system to mix the liquid fertilizer. Other system, there's the alert system and the notification. There's an event system to keep track of all the events happening in the system. And then they are the, oops, I've got two security systems there. Yeah, so the first thing one is the hardware design. So this is actually the rack controller board that we designed. So we have to do a custom design. This is done in, this is a PCB view. As you can see that the bottom part here is all the relays. I'll show you a video, and then this part on the one here is the one that connected to the sensors itself. So we did not buy any like existing hardware. We actually custom designed this board based on our requirement, and we have all the regulators and all the relays and all the power input. And I think this part is the where the Arduino Mega is sitting here. So everything is all done in-house, and we design everything. We are not like buying something and then we just slap them together. So this is all custom design, and this is how the hardware looks like. As you can see, the bottom one, this is the exact one that you see from the previous hardware diagram. The top here, all the power and all the ground, and the bottom part here, these are all the blue and white connectors. So we have to use some sort of connect, because this box here, this box that you see here is going to be placed on top of every rack. And this, as you can see from the top picture, we actually need to build like 15 to 16 of them, including spares with proper power cord and proper connectors here. I think the white one is for the lights, the blue one for the fans itself. And then we self-assemble this ourselves and self-test it ourselves. So it consists of an Arduino Mega 8 relay. I chose a LAN networking, so this is a wired system. Later I'll share with you why this design was chosen. There are multiple sensors here, and we were using these quick release connectors, and then it also complements with some air quality and CO2 sensors. So and then we just put it into this one of those common project box. And you can see this one, the most important one is actually the LAN. So this guy is actually a network connected system itself. So these are the technology stacks that we use. Lots of a lot of this is I probably have to clear this one. A lot of people thought that like Arduino is just for students or hobbies, or like used to be like nothing serious, and then a lot of the serious one they have to use some commercial PLC. I have to say like this concept is probably the large company marketing trying to badmouth a lot of these smaller things. If you look at Linux, for example, I mean, like during the early days of Linux, it's the same concept. People say, oh, this is all used by hobbies and home users. But if you see now, Linux actually power all the cloud server in the world, including Microsoft cloud server. They are using Linux for this. So these are some of the technology stacks. I'm using the Arduino IDE for the firmware for the racks. I'm using Ubuntu Linux, this logo here, for the server of the Linux. We are using an industrial PC. The protocol is an MQTT protocol here. And I'm using Node-RED as my low-code development. So this is the only one that I'm using for my backend. I'm using Node.js. Obviously, when you did your exercise just now, you need the Node.js to run all your Node-RED stuff. And then on my front end, I'm using VueJS. VueJS is a very popular JavaScript front end to run a lot of the front end scripts. It is a very productive and I would say very beginner friendly. So for people that are doing a lot of things to do with web-based, this is one of the very, very popular frameworks itself. So these have to be chosen, and once they are chosen, I cannot like change them, and then I'll just go with it and all. So this is the specs. Choosing your technology stack is one of the most important decisions, because this will determine whether your project works or your project fails. So we are using, I think most of these are, I think all of these are actually open source stuff. So no technology locked in. We do not choose like any proprietary protocol itself. So this can be easily replicated and duplicated. Yeah. So one of my case study I will share is that it is actually possible to build a really reliable system that is running non-stop. No, it's not like something that you build and then run it, do a video, and then just tear it down. Let me just stop a little bit and ask a bit of questions. Have any of all these things, which part that everyone has heard of or not heard of? You can use voice or you can use chat, doesn't matter. I record it.
Arduino I have used before.
Oh, okay, Arduino. Anyone else? Linux, Node-RED, MQTT, front end, web. Anyone else?
No.
Never heard of MQTT or Node-RED. Yeah, I think so. So as you can see, the Thursday, Friday good thing about attending those workshops because we wanted to at least give you a practical and real life case study, and then Thursday, Friday we can do the exactly we'll do the lab to get you going. We're going to do MQTT this week, so be sure to attend Isaac's lab on that part as well. So, as you can see, we have actually covered both the hardware, which is typically hardware design and running some Arduino, and also the software part, which is the node and server side and the protocol MQTT, and then the front end is actually VueJS. So we cover the entire full stack of technology. Anyone else? Have you heard of any or just can put it in the chat? That's right. If you do not want to talk. So I need to make the session a bit more. I'm gonna give you a bit knowledge, but I also want to get a bit feedback from the audience itself. Have you have not read or MQTT before this IoT workshop? Ubuntu Linux. Anyone?
Sound not clear.
Yeah. Now is it okay? Yeah. Let's since no response, let's move on. Yeah. So this is the as you can see, this is the dashboard. We give you what we call a line chart. So this is the first one is the live line chart of the power that's going on. We give you a live gauges. These are all the power gauges. So you could use many. I think in one of your exercise, you're supposed to do the gauges for the node rate here. Please do the practice. We got a live feed. There's a live CCTV feed here of the plant here. I can actually know that how well the plant is growing, and if the plant is growing at night or day and night. We have the system monitor here. We monitor the internet, the security, the power. There's like a traffic light, green, yellow, and red. If everything is green, then everything's good. If everything is like yellow or red, then something is not good, you know, and I get some events here. So this one gives you one snapshot of what are the things going on, and then I have the events down here. There is the level 2 event and the level 3 event. The level 2 events tells you all the critical item, which is in red color, and then the level 3 event tell you all the notification events itself. So this dashboard is actually open on the container itself. Later I will show you, and then we have all the logging. Everything here is being logged. Our system, all and the top here, the summary charts, there is the temperature, humidity. The most important one is the CO2, and then the CO2 is on off. So this is a typical dashboard. One glance, you know what's going on, and this is very, very important. And then in any IoT system, you will have to need to build a dashboard to combine all the different data together. So this is the dashboard part. So automation monitoring, fully automated, so all the log, all the CO2, all the airflow are all fully automated. Fully remote control, all the log CO2 airflow can be manually controlled. Yeah. Again, when you are building any automated system, you need a remote site to be able to override the system by a human, either remotely or either manually by the local operator itself. All major systems are being monitored. For example, like CO2's temperature, humidity, power, usage, and security. So I think for us, the most important is probably the CO2 carbon dioxide because the plant need to take in the CO2. Without the CO2, the plant would slow the growth and also the temperature. Make sure that the cooling is working well because we had a lot of LED light inside there and it generates a lot of heat. So we needed the monitor the temperature. Humidity not so much, and then the power usage is to make detect any major. So all everything is being logged and monitored. This is my design decision. So this decision comes why did you choose this over that? Nowadays, because a lot of especially a lot of the development come with a wireless. So people were asking, why did you choose a wired system? Wired system means that every box have a network connection to the local area network switches. So the reason we chose this is because, as you can know, we are inside a container, a metal box. And if anyone that study electronics, if you are in a metal box, you're actually in a Faraday cage. Your if you are running on a Wi-Fi or anything else, the wireless signal is going to bounce left and right. And I cannot allow if I were to send a laptop to run number 5, I need to ensure that run number 5 will receive the signal and turn on and off the lights. I cannot rely on something that unreliable wireless. Like I think most of us running our mobile phone that's running on wireless. If we did not get the signal, we can still retry, but in a industrial system, we can allow that. So a lot of these systems are on wired. I also wired up the entire container with Cat6 shielded cable to prevent any noise or anything happening to it. So these are some decisions that need to be made to prevent future problems from happening. So running it on a wired system means that all of them, they can ensure that commands are sent to the right controller 100% it will be successful. Second one is the right controller. Just like the little box you see there. Each right controller listens for command. So the right controller, as like an IoT hardware, a lot of the decisions, a lot of the logic is actually sent to the server itself. So the right controller don't do much. It will always listen to command from the server. The only time if the right controller, and this will actually happen once, when the right controller loses network connection to the system, means that either they cannot connect to the MQTT server, or their network, something wrong with the network module, or they lose the network connection, the light will blink. One of the light will blink. The reason we do that is that there is no way for me to know whether the rack is connected or not. So if they lose connection, the light would blink. If I were to look at the CCTV, I can see that one of the rack is blinking. Obviously, I will still know because I have lost connection to the server itself, but physically, those lights will blink. Then I know that something is wrong with rack number 2. I can send in technician to go and fix it. So I have a way to also let me not only on the system, but also physically to show that some of the racks are not working itself. The last thing, the EEPROM. So if anything, when they lose connection, they would save the last state in the EEPROM itself so that it can still run independently and still be able to operate. But a lot of the commands will be done. And then I'm using the MQTT protocol for sensor data and command to be exchanged. So the run controller would send, whenever it runs any command, it will send the command, the acknowledgement back to the server, which is the MQTT server. And then if I need to on the logs, I would send a command to the rack itself, or if I want to reset the box, I will send a command and I will reset the box out. As you can note, this route is very far away in Langkawi. If I were to send somebody there, it will be very expensive and it will be very, very slow to get the response time. So I have to use a protocol that I can remotely trigger and treat each of the rack as just a dumb box listening for command. So a lot of these decisions are actually made, and then that's the reason why we saw this decision. The box is actually very, very stable and very, very how to say stable, and uptime is very, very high. So we'll go into the details. We'll go into the details of the controller. Yeah. So before that, anyone have any questions about why I make this decision? Like, somebody asks, why don't you use Wi-Fi? Like, why don't you make the red controller stand alone and then talk to the cloud? Or another decision we make is that we actually have a server placed inside this controller itself. The reason is that if we lose internet connection to this container, it will still operate its own without internet connection. Just like we cannot control it remotely. So this is another decision that we actually make. Any questions on why the decision was made?
It sound not clear.
The sound is not clear, is it? Yes or no?
Sometimes sound not clear.
Sometimes. Besides Francis. The other people, do you hear me clear, or do you get a bit of the breakup of the voice? Yeah, let's go into the details of this design. In this details, I will show you some sample code, some sample flows to see how this works itself, and hope to cover everything within this entire session. So this is the content of the details. Like, I'm going to talk about testing. I'm going to talk about server and software. I'm going to talk about node-RED flows. You could ask more of the question about the node-RED flows on Thursday, Friday. I'll talk about the Arduino code itself. Talk about the event management. Talk about the button UI. Talk about the system monitoring, about the historical charts, and last we'll talk about the notification and alerts. So these are all the different details of the system that I will share with everyone. So the first thing is actually testing. So as you can notice, any system, like just like if you before you buy been tested for every system in it, from the braking system, from the health system, from the acceleration system, from the aircon, the entertainment. Everything have to be tested perfectly before a car is being shipped to you. So same thing, no trial. So I cannot have like in 3 months have another 6 months of trial, and then it should, so my system should run on day one. So I cannot say like plug it in and then still keep fixing the bug after bug. So this is like a commercial PLC. Now then I was saying that whether a system it is like commercial ready or not, it should not be saying that it is an Arduino that it is like a toy, no, it's not a commercial. That is actually not true. We can run this and we can build this as robust as a commercial PLC system itself. Location is in Langkawi. So as you can see, the only way to go to Langkawi is to drive to Korea, which is very far away from KL, or we can take a flight to Langkawi. So it is very, very expensive to send somebody or send an engineer to Langkawi. So the system, unless if I'm going to build a system in say PJ or or maybe in Malacca, I just within 2 hours I can fix the system. So this is a very, very far away. And, somewhere the things have to be make it very robust. Somewhere cannot fail. So first thing, the hardware cannot fail. Second thing, the firmware cannot fail because I cannot remotely create the firmware. That's like those Arduino or the no can still be changed and programmed remotely. That's fine as long as I have an internet connection. Arduino connected to the industrial PC can cannot be this one is like cannot be flashed remotely. Wait, let me I need to change this. Okay, so I have some other system on the Arduino. Those that are connected to the industrial PC, I can still flash them remotely. I think the two system was doing that, and ideally would have the ideally I would want to be able to remote grade the firmware, but due to the limited time, this system was dropped to the limited time. So it's like the many feature in the system delivery of 3 months, and the 3 months including designing the hardware, soldering the hardware, in the hardware, and then running the firmware itself. So it's not like just and then the other things like have to do the front end and the back end and all the other systems. So a lot of these systems are the key one is like the hardware firmware cannot fail, like the hardware firmware cannot have any bugs, and if there's any bugs there, then the whole system will just fail, and the whole farm can actually shut down. So the key to this is like when you're building a system, stability of the firmware is very, very important. So I would say that this would be a PLC commercial class quality already. So the server, so we are using a industrial PC for Axiom Tech. So as you can see that if you look at the palm, this server is very, very small. You only fit in the palm of your hand. The reason for that is that the container is used for planting. So all my space, as much space that I have to allocate it for planting as much plant as possible. So all these things, all the other things like server, network, switch, racks, and everything are just eating up unnecessary space. So the more space you put your equipment, the less space you plant, then your efficiency of the entire container, the productivity would go down. We only have limited of 40 feet container. So this is a very what we call a small form factor and fanless. So this system, as you can see, that it does not even need a fan there, because this is in a cooling room. The temperature is kept at around 24 to 25 degrees. This is good. The reason why we run this is, notice that this is with storage SSD. We are running an industrial SSD. This SSD are a bit different from the one we purchased for your normal PC. It's an industrial SSD. They should run and they would not fail at all. So these are the design decisions that is being made. This is the one that runs the Linux and the MQTT server itself.
Can we use Raspberry Pi?
The answer, you can use a Raspberry Pi for that's actually a very good question. But sometimes, because the Raspberry Pi run on an SD card, SD card are not designed to be having many read writes, because I'm writing all the sensor data to this guy continuously. If you want to run it on a Raspberry Pi, you need an external SSD to save your storage. It's actually possible to run it on a Raspberry Pi, and the newer ones are quite powerful itself. But so far, because for us, the cost saving is probably not the risk we wanted to take, because if I were to run on a Raspberry Pi, this thing costs around around 2,000 to 3,000 ringgit, depending on the configuration you choose. I think we chose an i5 with 8 GB of RAM with like 1 terabyte of SSD. Not some medium spec, not a very high spec. The reason we didn't use a Raspberry Pi was because if the Raspberry Pi were to spoil, because we use something that's not industrial based, the cost to change the Raspberry Pi would be too high. If the Raspberry Pi probably cost you like around say 300 ringgit, right? If I were to fly an engineer, if you buy the ticket from KLIA or maybe Subang to Langkawi, it will probably cost you 400 ringgit. I would have bought a Raspberry Pi by paying that is not the cost saving I wanted to achieve. For me, reliability is key. Yeah, but if like most farms are pretty crazy. You do not want your farm to be shut down for 1 or 2 days. So the answer is yes, you can run a Raspberry Pi, but if the Raspberry Pi were to spoil, your cost would probably cost you 2 or 3 times the Raspberry Pi. And after that, you might self buy one of these industrial PCs. Hope that answer your question.
Thank you.
Yeah. Any other question? What is industrial PC versus a normal PC? Let me just tell you why. If you notice that the industrial PC, usually they are industrial tested. These PCs are used in manufacturing and factory. They can put in the factory for 5 years. They would run non-stop, and they will not, like, the hardware are all certified and tested to run. And usually they have some special ports. And the back of it even the power jack is screwed inside. You cannot easily accidentally pull out the power. So they are made to last for minimal, probably 3 to 5 years. I would have said this one. Yeah. So people are saying, why don't I just get one of those DIY PC and put it there? Yes and no. I could actually get a DIY PC. First thing, the size would be too big. Secondly, thing is like I do not want to be, same thing as the Raspberry Pi. I do not want to be saying, oh, my power supply spoil, or my graphic card spoil, or my network spoil, or my motherboard or my hard disk spoil. I do not have the time to, within the 3 months, I don't have the time to go and build a PC, assemble, and put it there. So many moving parts. So when you run a project, you want your project to run smoothly, not sometimes cost saving is probably secondary, because once anytime when this thing goes down, your cost saving would be actually wiped out. Now is 10:46. Let's take a 15 minutes break. So during the break, I would like everyone to go ahead and I'm going to put this slide here. Go ahead and Google and look up all this stuff, like what is the Node.js, what is the Node RED, what is the VueJS, what is the MQTT. Yeah, take this 15 minutes, just Google and learn a bit more about this technology stacks. Yeah. We'll continue at 10 o'clock. Yeah, let's continue. Yeah, the next one is the server software. So once we have the physical hardware, the next one we will be using what are the software. So I'm running on a Ubuntu server. Ubuntu is a version of the Linux that we run. You could run other one. Typically, I run the Ubuntu version, and also there's a Node-RED. You need to run a Node.js server. I think all of you that done the lab, those that haven't done lab, please go ahead on the Friday one to run the lab to install the Node.js and the Node-RED. So I'm just running it just like a Node-RED server, and then I have an MQTT server running. I think this Thursday, Friday, we will be doing the tutorial on MQTT. Be sure you join the lab so that I want everybody to experience running on running the MQTT protocol itself. So these are the software that's being run by the server. Nothing too like you're gonna run nothing like complicated or nothing proprietary software at all. So these are the typical software installed on the Linux server itself. The next one is the Node-RED flows. Again, we started it last week. I'll go ahead and attend the Thursday Friday session. Node-RED is what we call a low-code programming. Low-code means that you use a lot of flow-based to do your programming itself. It is very, very easy to learn and very low entry level. The reason we write this is because I don't want to be running complicated line by line few thousand lines of code for this system because it will be very difficult for the show. It's so very easy to change itself. So this is what we did for this one. As you can see that if you look at this one here, I actually do a inject. I think last week we learned about inject. I could inject the time, say from 7 a.m. I send an inject, it will turn on all the lights itself. That's it. So anyone that can know how to use a Node-RED can actually change the timer without the programmer involved. And then I say at 7 a.m. switch on all the lights, switch on the flow. At 9 p.m. switch off all the lights. So that's it. So they just need to go right here, double click this to change. This will send the actual commands to the racks, and then you can see all the red lights. They will close it off itself. So the rest, let me just show you a live demo of this. It'll be easier to explain than this slide itself. Let me see where's my. Let me fire up my. Let me fire up this web. So let me log into my node itself. Let's go to the. Let's start with the ENV first. Environmental system. It might look a little bit. It might look a little bit complicated to you, but it's actually very simple. We get all the data from the server itself, and then here, this one, I think after a while you probably can understand this quite easily. There's this switch statement here. Let me click on it. So this switch statement say if you are between 0 to 28, that is normal, means that this is the normal temperature. If you go to flow number 3, if you are between 28 to 30, which is actually very, very hot for the container, go to flow number 2. And if you are above equal to 31, go to flow number 1. And if you are below 0, you go to flow number 4. Let's look at the flow number 3. Flow number 3 is this one, is normal. So that if you are going to flow number 3, everything is normal. I would trigger this guy here, and it will send out a normal temperature to the system itself. So everything is normal, no problem. I can also inject here to test the different systems. So the testing is actually built in. I really like about this. If you are between 20 to 30, which is quite high, it would send a medium. It would send out a warning temperature to the user. It will send to whichever that I want to send it to, and then it will set it out to the different systems. This is actually warning. Trigger lights off. Okay, also, you notice that I will trigger if it's very, very hot, which is this one here. If it's between 28 and 30 degrees, means that I assume that the aircon have failed. I would off the lights automatically via an automation. So if the aircon fail, I have to off the lights, because if your aircon fail and your lights comes on, the whole temperature is going to shoot up very, very high itself. I would trigger a warning. So as you can see, you can, even though you don't know any programming, you can go to the details. The lines are actually just a few lines only. You can actually read this itself. Medium, normal, medium. If it's high, what is high? Let's look at the high. High is above 31 degrees. This is very high. It's going to be very hot in the container. We will hit a trigger. It will notice. Obviously, at around 28, your lights has been switched off. And this one, I would trigger the warning here to send out very, very high critical warning to the system. Later you can see during the notification system, they would receive this one, and this one actually send it to a Telegram bot itself. Yeah, I think this is my development tools. So as you can see, even this one, everyone that even you don't know any programming, you would have know how to set this one. Below 0 is error. Between 0 to 28 is normal. Between 28 is 30 is warning. Above 31 is high. So no programming needed at all. And then if you can see some of this one is just conversion of not like I'm going to like a few thousand like. So it's just a conversion. And then here, this one, if you look at it, I have to construct the message to be sent to the Telegram. That's it. So nothing too complicated here. Yeah. So the flow itself is actually quite simplified. What else? Let's look at let's do another example on the CO2. So same thing. Carbon dioxide comes in here, go into a switch. If it's between 0 to 599, it is flow number 3, is considered low. If it's between 4,000 to 600, it's considered normal, and above 4,000 is considered. So in the CO2, normal, figure normal. Let's say if I'm means that something is wrong, or what I mean by something is high, the CO2 is very high. If the human were to enter the container, they would get CO2 poisoning because the CO2 level is too high. The human will get headache or nausea because we cannot breathe with too high CO2 content. This is actually quite dangerous. Actually trigger and make sure that no human can breathe. And it is low. I think low is below 400, below 600. It's no good for the plant itself. So we want it to be normal. Then again, you see this is just you would have easily learn about. And you could actually try this out in the switch itself, like nothing programming needed, just put the flow itself and do a bit of trigger and look at the trigger. Yeah, just set up a programming for the system itself. Anyway, if I were directly the CO2 burners, this will automatically trigger, so no human. As you can see, in my way, the wiring here and there, but actually, once you follow through, they are actually quite easy done. You need to be a bit more familiarized with the system, but other than that, they are just like flow, and I'm getting all this flow. And itself. So siphon of the flow into the database for logging purposes, and then there are some. And let's look at what's this. So I just remove everything except the CO2 and so nothing too complicated stuff is being done. And let me look at another one. Is the let me look at the other one. Is the dashboard one. I could run the dashboard from here. I just double click here and then I'll just open the dashboard. As you can see that I actually get the actual dashboard running itself, and you can see about the temperature, the humidity, the temperature charts, and some of the power gauges. I think these are just random values. And I can have all the traffic light running, and I can set all my timer and everything here itself. Yeah, so you can have all your these are all the total power. If you want certain power, these numbers currently are actually just random numbers for visual. These are not real numbers. So that I can actually have the dashboard up actually pretty easily. Yeah, so they are not that they're actually quite easy to be. And then all the days that I will just feed in whatever data I get into this system itself. I will get a very nice dashboard for this one. If I really want to, let me just show you. Let me just show you how this one runs, and I'll just go to click on edit file. Let me look at let's run through one of them very quickly, and you can see these are all VueJS. These are HTML stuff. If you know the web programming, you would see this is quite familiar. We put in certain data and some of web programming should see that these are all HTML pages. So nothing. Let's say I'll just say these are HTML pages and it's a big number. Big number is like it's going to be making the fonts very big. Nothing too fancy. So this one is the VueJS part. If I want the event, I will just get the event value. So I'm going to web programming. Most of them full programming. This is how we run this one. Very easy to maintain and very easy. So nothing too complicated. And this is the buttons. The buttons are the ones the buttons are the ones that one of the buttons I can open I can turn off the lights and on the fan from here. This is just the test version. I can on off all the lights from here. Red 1, red 2, red 3, red 4. All the reds are all here. So they are all done in this menu. Yeah. Yep. So And events, yeah. So there's some of them. I'll talk about the events a bit later. So you can see the functions and just different system going in. So these are just manipulating the data. The next one is the so the code will just briefly show. This is the code for the web controller. Yeah, as you can see that this one was last updated was October 2019. So the reason this code was updated was actually no the reason it was updated was actually November 2009. So you can notice this is the code that is running on the system itself. We have not updated the code at all, and then it's like only 2 versions. I would say that what are the changes I made, and I would make a bit of minor change. So the last time I finished the code in the racks is actually November, or let me see. Oh, it's almost like 2020, 2022. It's almost 2020 and 2021. So it's almost 3 years ago. I mean, 2020, 2021, 2022. Yeah. So now it's also oh, actually in fact it is actually today's date. Yeah. Now today is the 21st of November. So this form has been running for 3 years. And then typically we have to run all the these are all the definitions, we have to run some Ethernet, and we have to run the PubSub client, the MQTT library for the Ethernet, and some defines, some div, some struct, some relays, and then where my MQTT server. If you're doing Arduino programming, you need to know a bit of this. Where are your MQTT server? This server is the one that is running on the just now the industrial PC itself, and and then it will receive the data from the MQTT and then process it. Let me give you an example. If I want to reset this guy, I would have sent him a reset. I could send a reset to the this is from the server. If I send a reset, I would just reset the Arduino itself. That's it. Wait a second. So reconnect. If this thing goes down, it will reconnect. This is how the some of the subscription works, and then and if there's any errors, a lot of these are actually sample codes. Excuse me. Yeah. So if you're familiar with Arduino, you would have seen some of these things quite. This one is not very long. Probably like after the comment, probably like 500 lines. So this is the code where I cannot change that often. So this code is the one that I would have to make it very stable, and then I do not, because if I need to upgrade the code, I would have to upgrade 15 racks itself for this code. So this one is actually very this code is actually very stable itself. Next, let's look at this. Let's look at the event management. So let me go back to the. So in the event management, whenever something happens, the lights come on, the lights goes off, I would record an event. The door open, the door closed, I will record an event. The reason I need is that it's like I would say if 10 a.m. or maybe 2 a.m. in the morning, suddenly my door open, so I know that somebody broke into my container itself. You know, like it would trigger an alarm and events. I have 2 doors. If something goes wrong, I would look at when the lights come on and when the lights go off. If suddenly the box keep rebooting, I would be able to see those events and trigger the alerts itself. The event have typically 5 levels. These are the 3 levels: the critical, the warning, and then the notice. Let me show you this one. This is the critical event. Critical event is like something that is very important that the user need to take note. Like for example, when I run out of gas or the temperature is too high, the temperature is above 31, it would trigger a level 2 a critical event. So this one is something that user technician have to immediately take action based on this event. So this one, I think it's pretty standard. All the industrial one have something similar like this. And level 3 event, just say, you know, like, is my CO2 on? Is my CO2 off? Is my lights on? Is my lights off? So in this case, you will notice that rack number 4 have problems because 917 it keep on connecting to the server itself. So I know that there's something wrong with rack number 4. I can get people to check this one out because it should just connect to the server one time and not every time. So with a lot of the logging and events, I know everything that is going on in the container remotely and automatically without even knowing what's going on itself. Let me show you the interface for this one. This one, get this first. This is the events, and we double click here. This will be a blank event. In an event, I can show you all there's no data here. Critical event 2, notice, level, and debug. Or I could say, what are my environmental event? Give me my rack event, give me my sensor event, then I can clear the event. So I could query all the event quite easily just from the user interface itself. Yeah. So bear in mind that all this has been written in a very short time period. That and all this was written from scratch within the 3 months, from the hardware all the way to the firmware and to the software itself. So a lot of this is a lot of them is the web programming. The next one is the button one. Let me show you the video of the button. I hope so it's running. Yeah. So this is the board that we were testing. As you can see that I can use the tablet here, web-based, and then I can on off I can toggle individual, the fan, off them together, or I can toggle the so this is how this part, once I did the programming and the firmware, I would have to test it with the UI. So this is just a tablet with a web-based interface. This interface is the one that just now I show you. So a big part of it when you are doing a lot of this IoT project is actually testing it. So this is how we test it. So then next time the server would send the commands this way into the they will send the commands this way into the service, and of course I could also remotely send this command from when I securely connected into it. Okay, yeah. So let's look at the buttons. Yeah, so these are the buttons. A web interface to turn on and off the light and the fan. You just saw the video. It's a bit easy to explain with the video. And so the UI one was probably the big one because everything runs on this. And before we come up with the timer, we just manually on off the light itself. Show you something. This is something we to test this one. Let me show you this in a moment. Slides, picture, yeah. So let me show. So we are doing something fun. This is like we are like doing like a ghost movie like that.
Oh shit, that's so
Manually turn on and off the lights.
Okay.
Like we done it. Like we done it in a like a ghost movie. So I'm gonna off the lights one by one, and then you can see that the light all like offing, something like this. We're just having some fun, kind of like a ghost movie where everything gets dark. And I can notice that I off the light one by one, and then the last scene is like all the lights get off. So not need doing serious enough. Just have a little bit of fun playing with this itself. So the next one was the system monitor. So the system monitor would monitor all the system, whether it's green, yellow or red. I can monitor either the door is open or the door is closed. And when is the last time the door is open? Same thing for the CO2. Is the CO2 on, CO2 off? And which rack is on, which rack is off? And then the power, is the power normal? Is the power any critical? So everything we monitor is going to turn green, yellow, or red based on this. So this system is actually, if you look at the flow, is actually here itself. That's what the system monitor. System. Gauges, events, this system right now. I don't know where I put it already. To the Sysmon. Send to Sysmon. I know where this one is located. Extract buttons. Yeah. So this one is the button. Events, gauges. I have no idea where I put the one. So again, all this is all written. The logic is all done in the Node-RED itself. The next one is the historical charts. So not only that I have to monitor all the current data. I also need to monitor the historical data to understand the entire system better. This is to analyze the trend itself. If I get so that I will know that at what time, what is the power usage. This one can detect potential issues and future issues, and also where the power is being allocated. Just going to show you some slides. So this one is like the as you can see that this one, the green one is the rack 1 to 8, the one on the left side, and the right one is the green. So you can see that I can see the power. Obviously, during the night time, I don't use much power because the lights are off. And you can see from here. And during the daytime, this is where whenever they are stabilized, I would know that when the lights is off, is actually very low power, and this is when also the aircon. This is the bottom part is actually the aircon and the cooling. This is done by the 3-phase power, and that is the total power. So this one we have some problem here, and then we actually are able to solve it. And we also monitor the main power. As you can see that my power turned on at 7 in the morning and turn off at 9 at night. So I can see that this is a nice one. The total, this power are actually the aircon power. As you can see that my lights use up quite a bit of power when the lights is on, and when the lights is off, it's actually very cool, and also the aircon doesn't create. And then I also monitor the voltage. Voltage would be nominal around 220 to 240. If the voltage goes up too high, you would know that there's something wrong with the system itself. So you can also zoom into the chart. Certain time, what is the power and what is the voltage and what is the meter. So after a while, I would get a very consistent chart. I would know that what's going on and where if any problem or any of the phase is going to be going crazy, or if my load is not distributed evenly, I can see it from here. So monitoring the power, especially for any high power application, is very, very important. And this one, the chart can actually tell you, like one look at this, I would know that my timer is correct because it starts at 7. You see the power shoot up and then it off at 9 sharp. So timer, if you configure the timer, I can tell from the power chart itself. So as you can see that even when the power is on or off, they should not have a significant drop of the voltage itself. So a lot of correlation is being done to address all these things itself. So this is how the power thing is being monitored. And last one, let me see, now it's around 10:30. Yeah, okay, let's so the last one, we are using Telegram for monitoring. So as you can see that we monitor things like if the temp is high, temp is low, and it will send out messages via Telegram. We add our support and technical staff to the Telegram group, and then I will be able to, they will have to respond whenever there's like a high alert or there's some sort of alert. That I can also query what's going on this Telegram. The reason we use Telegram is so that usually we use our chat on WhatsApp. We will have too many messages on WhatsApp, so we typically use Telegram. And also Telegram API are pretty easy to configure. Let me just show you the Telegram part. It's actually just here. There's some error about this one. I create it and then I will send it to the Telegram sender. You just configure the API, and if you look at my ENV here, you can see that anything that's blue color, I would send it to the Telegram bot itself. Actually, it's pretty easy. I configure the message, warning, what is the message, and it will get sent to the Telegram bot itself. This is the development one. That's why I don't see anything in the error. The live one is actually working. So I would say, okay, critical, blah, 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 it will be sent out to this one. So this is actually, the system itself have to work, and then all these things have to be done in a more seamless manner. Things like get quick status via Telegram. Like if I query, say, hi, my name, last message, when, what is the CO2 level, what is the temp level, door 1 is open, door 2 is closed. So door is open, maybe somebody is doing some mixing, door 2 is closed. CO2 general. So this is the query that I can send a query. I say, warning, blah, 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 CO2 is high. So the second CO2 is very high at 6,000, then it's off, like it will give you like warning. So everything is being automated and alert. So I don't even need to log on to the system. Maybe I'm outside. I'm not going to be able to open this dashboard when I'm outside. I'm not going to be able to open this dashboard when I'm outside. So typically, I will just look at the Telegram message here so that you can quickly respond to it. Maybe outside, you should be able to see what is going on here. Yeah. Let's see. Now it's 10:30. Let's stop here a bit and open up for a bit of questions. Any questions so far on the detail side? From the, let me see. Let me go back to the detail page. So, any questions on the testing server flows, Arduino event, traffic light, historical and notification? Yeah. Any questions so far? Let me pause for questions.
Just now about the hardware side, I forgot to ask this question. If the SD card just read only, then no problem. If read and write, then there will be problem, right? Is it correct or not?
Yes, but then again, you notice that if you look at the one, I am logging everything here. You notice that I'm logging all these charts here. I need to write data to the system a lot. So it cannot be a read base.
But if we can write to somewhere else, then it's okay lah, right?
Write to where then? My question.
Hard disk or something or somewhere lah.
Yeah. So you have to attach like a hard disk to the Raspberry Pi. Yes. Then that's fine actually.
Thank you very much.
Welcome. Any other questions? Any of these questions? The one that usually you don't see is actually the testing, because we have to test it, test, because it should work without failure. Like if you don't test it, you get a lot of bugs when you start to test it. Any other question? Anyone know what's Telegram? I assume.
We are using Telegram.
Oh, okay, good. Yeah. Questions for anyone? Arduino hardware, node rate, MQTT, any other question?
This one, Arduino, if we use Raspberry Pi Pico, also can, right?
Yeah, it's as long as because for me, I have a neural interface, so using the Arduino would be. You can use Raspberry Pi Pico for the microcontroller too. Just that make sure you have all the libraries, like all the MQTT libraries or any other libraries. Yeah, the programming should be similar. I think the Pico can be programmed using an Arduino too. As you can see here, I actually can run this on a Raspberry Pi Pico. Yeah, these are all the boards that we support, all the Pico things. Yeah, no problem. The only problem with the Raspberry Pi is because there's a shortage. You cannot order a Raspberry Pi now.
Can you repeat? The sound didn't go so good.
The list is out of now. You cannot order them. The Raspberry Pi is out of stock. So you cannot order them. Maybe unless some places have like extra stock. And places they are totally out of stock.
Can you repeat? The sound not so good. Thanks.
No, what I'm saying is that I have the same. The Raspberry Pi problem is like the Raspberry Pi is out of stock. You cannot order them.
Thanks.
Any other questions? Historical chart, Telegram, system monitor, button, UI, event management. Any other question? If no question, I'm going to take a. Let me see. I'm going to take a. I will leave. I'm going to take a short break now. It's 11:40. We will continue at 11. So the 20 minutes. The 20 minutes. Go ahead and do some searching about all these things like what is Node-RED, what is this UI, and what is this why are those historical charts is important. Yeah, we will continue, and I'm just going to put that continue at 11 a.m.
Thank you. Thank you.
Yeah, take this time and go and open up your browser and query some of the stuff. I will leave it at this question.
No sound.
Yeah, okay. Yeah, hi. Okay. Hello, everybody. Let's continue. So the last is that nothing but I'm just going to show some random pictures and things just to give a if you're running the physical, the physical container is sometimes it's kind of hard to visualize it, but I hope the those video does help a bit. I'm just gonna show you some pictures before we summarize the whole thing. Let me just see in no particular order. Yeah. So this one is the actual relay controller, network-based relay controller, using and running an Arduino with relay, and you can see that there are a lot of like quick connect here at the side here and some sensors here. Next one, yeah, this one is where we actually manufacture it ourselves. We actually sold it everything ourselves. So again, it is not like some product I bought from Europe or US and then I plug it in. We actually manufacture this ourselves one by one and do it this part. And also this is the CO2 burner. So this is the one that it runs on gas and then it will burn and then you release the CO2 on top here. So this one you'll be sucked into the vent and then you send the CO2 to the entire, and this the bottom here is actually the controller here. So this is the CO2 burner for those that want to know what's going on. So this is the one that supply all the CO2. Again, if you are doing anything to plant, CO2 is very, very important. This is the 5G modem. This is the 5G modem from Huawei itself. So this is the one that is like the entire container is powered from this 5G modem. This is the external, so this is where the modem was installed. The other two is actually the 4G and the backup modem. So we have the 5G as the primary communications with some CCTV here and PTZ CCTV, and this one is where the power comes in. Here is where the backup, we are using the 4G as the backup and running on the 5G modem. Yeah. So this one is a real 5G container. Yeah. And then this is how it looks like inside. As you can see that this is where the first rack is where we do all our germination and stuff like that. And then what we put very, very limited. So you can see that the top here is one, and then we have a monitor here to run the system. So this is plugged inside. Then where all the monitor, the display. As you can notice that this is actually running on a little Raspberry Pi just for the display only. We're running this on display because the actual server, this server itself, we are running it what we call this server or the server, we are running it headless. So the server have no user interface. This is running it on command lines only. Yeah, so we make decision like this. And this one is stowable. We can move this around, and then this area and the top here, this is the distribution board with all the power and all the DB and everything is here. And then the bottom part is where the agronomist doing all the mixing. As you can see that I have totally no space at all for equipment. So everything is dedicated for planting. So the primary is to have everything planted here all the time. So this is a actual view of the operator. So the operator can see all the temperature, all the humidity, all the CO2 from this screen itself. Yeah, this one I show you already. At the back here, there's actually a window. You can just, people from outside can just see what is inside here. And these are all the lights. These are the lights here, and there's the airflow. And we have this trolley to reach the upper part of the container itself. And this is the poster from TM. It's a machine farm. It's about the hardware. It's about the system monitoring. It's about the agronomy. So it's about everything, hardware, system, and agronomy working together for this is the 5G Digital Malaysia. It's actually sponsored by Smart Agriculture. This is actually sponsored by TM itself. This is actually the poster outside of the container, and this is how the container looks like. Outside here, you can see this window. You can actually come in and see. You can look at it, what is inside. It's kind of like a transparent. When you go to those restaurant, you can see the cook doing the cooking. So this one you can actually see here and look at how the window, you can see inside all the plants and going on, and there's nice poster here. And this one was done during the launch on January. Some paper. Don't read the bottom article here. So I was doing some testing on this one on one of the thing here, and this is how the whole thing works. It's actually a smart farming solution with on the 5G and with the internet. So this is how long the entire container actually looks with a nice decal outside. It looks really beautiful. What else? Let me see. Yep. That's about it, I guess. Let's see. Any other thing? I've nothing much. Let me just summarize the whole thing for everyone. So the summary one was that this is, I would say, the first ever 5G farming container. I think we're probably the first in the world, and it was actually launched by the Prime Minister of Malaysia in January 2020 in Langkawi. So imagine the amount of pressure the whole team gets, because we designing everything from scratch, and we design from the hardware, the software, the system, and the user interface. Everything was designed from scratch. And then I cannot even delay the project, because the launch date is actually fixed. And then first time, we're gonna not launch by any minister, it's gonna launch by the highest, is launched by the Prime Minister in Malaysia itself. So there's no delay, everything should work from day one. We probably have one of the highest volume of farming. So we could, when we harvest this, we could actually do 3,000 plus hits per harvest. One hit is actually one of these plant in the term. One of these boxes is actually one hit. Typically, we count it in the we count the hits in the number of harvests. So this is a very high volume, and then I think the system is still running today, since it was up in December. So it's almost like 3 years. The system was still running, and you can see it was still running in testing. Like look at the video. So one of the reasons Dustin uses this container or any other containers, would you need something like this? Because any of the 5-star hotels, or especially in Langkawi, they were importing vegetables from Thailand itself, because they're in Langkawi, and when the vegetable arrived, it was all very in the right position within the mix. This one
Not clear. The sound not clear.
Oh, the sound is not clear. Yeah. So the reason why is like they import all the vegetable, all the salads from Thailand itself. So this one, they can actually get it fresh from the farm itself, and then so all the thing they are getting is actually fresh. And if you ever whatever veggie you get in the supermarket, they were probably like 4 or 5 days old. If this one, if we were to harvest this vegetable, it can probably last a week in your freezer, and you can still see it's very fresh. So the value that you are eating here or we are serving it to the people, the hotels is actually super fresh. You could actually smell the freshness. So this is where having I would encourage everyone here to doing a lot of like urban farming. This is a very big market. This is a very big industry. And, you can and then even though it is a little bit more expensive, but if you can get the correct customer, they're actually willing to pay the good price for this one, for this volume itself. I'm just going to show. I'm just going to put back on the first page there. Yeah. So that actually I probably want to open now for any Q&A session or any session. I think I covered quite a lot of topic here from from the this is probably the slide I want to show. Yeah, from like software I just covered a lot of things, software services and everything from like from Arduino codes to Node flows to the user, and then there are tons of other things like all the mechanical stuff and all the M&E stuff, all the power stuff. I did not totally cover them. Those actually are actually quite detailed also, how we did all the fabrication and all the metal work and how the wires are being pulled. All of it was covered. Yeah. So quite a very detailed. So many teams come together to work on it, and of course I only cover all the software and the electronics and the automation part of it. So it's like the entire thing is actually very complicated, and we are able to pull this off within like 3 months, which is actually I would say a record feat itself. And then all the only I guess the only question that the Prime Minister asked was that first thing, is this system made in Malaysia? He said yes. This whole thing was entirely like made in Malaysia. All the boards were designed and we fabricate everything. All the software was actually written, and tested. Not like, so this one, as you can see, like we did not go and buy a complete product and put inside that. So only the lights and the top part is of course we are using like aircon cooling. Every other thing, even the boxes, everything is all fully designed and made in Malaysia itself. So that part is actually very important. I'm going to close this. I probably covered the end of my presentation. Like covered a lot within the 2.5 hours. I'll probably open up for any Q&A or any of the sessions that you would like to know more about. So again, the node rate part, we are going to cover it in the MQTT, and the node rate part, we are going to cover it on Thursday and Friday. So make sure, where's my participant? Yeah. So make sure, if you are interested to know more about the MQTT and the node rate, attend this Thursday and Friday session. We will cover what is MQTT, what is we are going to use some node rate to pull some data. So typically we're going to do something like this, but slightly a bit more simplified. Yeah. And I'm going to open up for questions. You can ask questions via the chat, or you can ask question via the voice. Why did I'm just going to show this one. Why? Yeah, this is a good time to ask the question. why do you do something certain way or not another way? Like why do you use this and not that? Yeah, I open up for question now.
If I use Python also can, is right?
Yeah, actually, doesn't we are not really agnostic to the programming itself, but if you use Python, just make sure all the libraries that you are using is there. The system is not going to be running a very smooth processing, so I guess Python would work exactly the same thing. Not mine, because I'm running on Node, right? And then a Node is actually a JavaScript based. All the scripts here, you would still need to know a little bit of JavaScript, because this one is all the detailed function is actually written in very, very basic JavaScript. But yeah, you could run it on Python, no issues.
Thanks.
Any other questions? I open up now for questions or anything you want me to explain a little bit more, or like.
By the way, if we want to install a sensor for the car, example, so that we don't get knocked at the side of the car, it's simple also. Simple thing with this from this or this simple thing, or very complicated, or control with a smartphone or handphone.
A car?
You want to sensor the side of the car so that you don't bang against your neighbor's car.
Good question.
No, just a application. I'm just thinking of some application, so just trying out some example lah.
You have to do a kind of thing with probably some ultrasonic sensors.
But the ultrasonic one, the one which is compatible for Raspberry Pi, do you know, is not industrial grade for outside use in the car, is it?
Okay, let's take the on this whatever the topic we are discussing today.
Sorry.
Any question from anyone else? This is one of the things you need to know more.
So like you want to make a drone and control from a tablet, all that, so can do that.
Drone will be a little bit complicated, because you have to be like knowledge of the drone and RF and everything. Yeah. So typically drones are controlled using the RF. Okay, again.
Sound not very good.
No, I say the question is not off topic again. We are talking about IoT, and we're talking about systems. Typically, the controlling are based on RF, or maybe they wrote some application on the computer itself. Over time, you control a drone from remote control, remote control.
But we can try to control from the tablet or that, or smartphone.
It will still be reached to a radio controller. You can, but it's always still you have to send radio frequency to control the drone itself.
Thanks.
Yeah, those are I would hope typically you would the reason we have one section is so that you can ask your questions. If you if you are asking a question, you might as well just watch the recording because you have no need to interact with the speaker or maybe like get your question asked. You can ask any question. I mean, if the question is unrelated, I will tell you it's unrelated. Yeah. Like this is still what a very big industry, and as we move forward, things get automated. So ability to ask questions is very important in the learning process. Just 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 excellent. So we make sure that there's like sequence. And like, there were 19 participants minus me, and there's like 17 participants, so like more people actually ask questions. If I think of it, one thing they can ask me via the chat, doesn't matter. Ability to ask questions is actually how we I'll keep the channel open until 11:30.
Sound no good sometimes.
Yeah, okay, thanks.
Thanks, bye.